Welcome back, Precalcsters. Today is Thursday, August 29th, and can you guys just remind me of my opinion on Meredith Grey?
You hate her.
That's right, she's the worst person ever. All right, let's talk some functions. I hope it makes people smile. It makes me smile. Like, that's the thing. You don't have to laugh, but I enjoy it, so I'm going to keep doing it. All right, a relation where for each element in the domain, a single element from the range is outputted. Now, remind me real quick, because I just have this terrible memory. What's a relation? That is correct. It's a set of ordered pairs. Could be ordered triples if we were in 3 dimensions, but we're not. So we have that. Now, if we want to be really, really formal about this, and of course we do, why would we not? We're going to get another definition. We're going to draw a picture for it as well. So this is like a pretty formal definition of it. There was a worksheet in the book that I gave you earlier on the very front. Have you ever seen most of those symbols? We're going to do a notation short quiz on Monday. No, cool. Tuesday. I would just have not done it before, but yes, thank you. All right, here we go. So let's say that we want an actual formal definition. Now, we know that it typically goes from the x to the y, but that's just by convention. I could call them anything I want, right? Literally anything. So when we're looking at this, we're going to say a function. And we haven't talked about naming them yet, but you guys have seen it. If I were to name a function, not like Jeffrey or anything like that, typically with one letter initially, what's the first letter you think of when you think function? Something of x normally. F is typically where we'd start. So we're going to say we have a function, and we're just going to call it f. That's it. That's the function, f. Okay, a function f from that, and I'm going to even add language, that maps elements from the set. And I'm going to let you guys catch up because it doesn't really matter. When you're naming a set, it's a capital letter. A single manuscript, non-italic capital letter. So I'm going to map, instead of saying from x to y or the domain to the range, we're just going to say, hey, my function f is mapping elements from the set A to the set B. So from A to B is all we're doing. From the set A to the set B is a relation, first of all. And that's where we kind of, like we have that language up here, is a relation for which each, and this is, you're going to see like the irritating creativity of mathematicians. The set is A, capital A. What do you think we're going to call something from the set of capital A? What letter would be like the most possible confusing one we could use? Lowercase a. Hey, that looks awesome. For which A in the set of A maps, not mabs, weird, maps to a single. Now, again, we're sticking with that mathematical creativity. Elements from the set B are going to be named. Indeed, it is B in the set of B. Okay. That's more formal language because I don't really care about language, domain, and range. Those are just what we call them, and we will call them that like consistently. Looking at this, you guys ever seen the word maps in math? Okay, so check this out. We're going to get a picture of this, and it will become super duper handy once we get to compositions of functions. For now, you might look and go, that's stupid, I hate it. That's okay. So we're going to draw 2 sets, and they're going to consist of some number of elements, and we're going to make it easy. So this is going to be a set A, and let's just say in here we have A1, A2, and A3. It's beautiful. Okay, I'm going to take my function, and I'm going to grab something out of there, and I'm going to map it or move it to a different set that we call what? B. Okay, so check it out. Here is our wonderful set B. And let's say we have B1 and B2, so it's kind of wonky. Love it. All that I'm going to do is I'm moving something from A to B. That's literally all that happens. Now, when we think of moving something, when I talk about mappings, I'll show you specifically, but when you think of a function, literally all you're doing, that is F right there. And it can come in a whole lot of different varieties. It can be really fancy rules or not. F is just the thing that our machine that grabs this and puts it here. So I want to look at a couple things. We're going to do one with this, which this is just a talk it out problem, just so you know. I don't want you to add anything else to your picture. That's our function. Now, when we talk about mappings, here's what we're referring to. Is it possible that when I plug in A1, it spits out B1? So if I said A1 maps to what would you say? B1, okay? A2 maps to what? B2, and this is going to irritate you guys. I'm going to do that as well, where it looks like A3 maps to B2. Do I have a function? Now remember, in which each A from A maps to a single B and B. Did I have a single A value mapped to more than one B value? So careful, that language is really specific. I think you said no, but you might have just been yawning. B2 got used twice, right? Like I can see it gets used twice right here. But how many things does this map to? How many things does this map to? Again, I'm not flipping you the bird. And that one? Does that follow this rule? So, is this a function? I'm going to break it, maybe. I want you to tell me, does this break it? What do you think? Is that a function anymore? Why? "20 seconds, talk with your neighbors. Don't care if it's a good reason, bad reason. Give me a reason for yes or for no. Don't care. Pick one and choose at random and then justify it if you want to." Okay, just hands up. This is a function still. Okay, hands up. This is not a function anymore. There's specificity in the language. Everything in A needs to map to exactly one thing in B. Now, this maps to one thing in B. Cool with it. This maps to one thing in B. Doubly cool with it. This maps to how many things in B? Get out of here. That's not a function anymore, unless we make some restrictions. Okay, one more. Are you guys baseball fans? All right, if I say I'm going to throw an ephus at you, any idea? All right. What? Not a Nerf ball is a good thought. Curveball is what people normally say there, right? That's a more common expression. I want to throw you a curveball real quick. Ephus is when I throw it like straight up, like I'm playing catch. It's really hard to hit. Anyway, they don't throw them very often. How about now? And we'll even let that one, we'll put that back in so that now we have everything in A does something. Is that a function? No. Why? Hey, that stinking A2 breaks everything. Okay, now I can present them like this. There's another way that we can present this. And we need to see it, but I'm not going to go crazy with it. All right, we're going to do one example, and we're back to red, so I want you to write it down. Because it turns out this isn't the only way. This is a way to write a set of numbers. This right here is a set A, and this is a set B. However, there's another way to do it. So I have a simple question. On this example, I'm just asking, is this a function? Okay, whoa, I stopped looking at it clearly. Is this a function? All right. So here we go. Instead of drawing our nice or terrible picture, we're instead going to just have a nice relation that's ordered out here, and we're going to make sense of it. Let's say this is S, capital S manuscript, and then set notation. You guys have seen, some of you are better at drawing it than others. Curly brackets are what we use to indicate a set. Okay. So I have a set here, and I'm going to shove some things into it real quick. Let's say I have 1, 2, 2, 5, and 3, 6, and I'm content with that. Feels like a pretty different question, I think. Now, looks different. Like almost like we haven't talked about it, I think. Can you guys tell me without writing it all down, because we're actually just getting to is it a function? Regardless, is it a relation? Is that a set of ordered pairs? All right, check that off the list. Can you tell me the domain of that relation? 1, 2, and 3. So you will see this immediately. You don't have to write it down, but just so you know, if I were to write this, the domain, dom with S like that, do you know what I'm referring to? The domain of S. And you don't have to write this down unless you want to. It's 1, 2, and 3. How'd you get those numbers? Oh, yeah, okay. All right, how about this notation? We haven't talked about it, but I think you'll be able to reason it out. So you can give me the numbers. You said 2, 5, 6. And what is that shorthand for? You're right. Give me another word that maybe ran is derived from. It's the range. Okay, so we see that we have a relation that has a domain and a range. They do. Could we draw a picture like this too? 1 maps to what number? 2 in the x in the domain maps to 5. Okay, right now there's an easy way to check this. Do you have a single x value that shows up more than once in this list? Is it a function then? We're getting funky right now. Yeah, this is a function. So, yes, easy. If I wanted no, and I'll say, I'll justify, no x maps to more than one y. We don't have to write this one down. More than one y. But I want to just ask something. I want to break it. I want it to stay a relation, but I don't want it to be a function. And you guys don't have the ability to erase as quickly and cleanly and stuff without messing stuff up. I'm going to add it in black. What could I add to this so that it's no longer a function? There's infinitely many choices. Talk it out. I'm going to call on one random person. Like 20 seconds. What I'm going to add, so notice I erased the brackets, I'm going to add one more point in that relation so that I don't have a function. 3, 2, 1, and the winner is number Rafa. You're 12, right? Rafa, what could I add that would make that no longer a function? Okay, so literally give me any answer, a full answer. Why am I broken? 1 maps to 2 and 1 maps to 4? Not allowed. Now, infinitely many answers. It could have been a 1, or it could have been a what? A 2 or a 3. Okay. It's easy to pick out when you see it like that. Is there a graphical representation of this, like a test you guys have heard to see if a graph is a function? Holy vertical line test. Does a vertical line touch it more than once? That's the same thing as being addressed here. All right. Can we move out of the nitty-gritty stuff here? Kind of, at least. I'm going to blast through these pieces. Do you guys remember doing piecewise functions? Okay, you will, and you'll remember how much you loved it, I bet. So, I'm going to go kind of quickly through this. we represent functions using like letters, right? So we're going to have a couple things. It can be challenging to tell without a graph if something's a function or without a whole list of ordered pairs. So I have a little subsection here. We need to testing, weird, for functions. You don't have to write it stupid like that, but I enjoy it. Cool. Right off the bat, if I write something as f of x, it's a function. Like, I will never trick you with that language, but a lot of the time it's not just there. So I'm going to leave like a couple lines here. I'm going to write something here in just a second, but I just want to jump right into an example and see where does our brain go. So same questions we asked before. Is it a func? And I'm just going to stick with that as my shorthand. Okay. Let's check it. Part A. Here we go. You are not allowed to graph this. Ooh boy. All right. I have the following equation. 2x squared plus y plus 1 equals, let's get real crazy, 0. The question that we're asking, without graphing it, and I'm not going to give you a relation with a list of infinitely many points, I'm not going to take the time to do it. All I want to know is it a function? Now, I'm going to give you a second. It may be hard to determine that. I'm going to give you a different type that'll have a different answer. I'm not going to tell you which one's which answer. We're also going to write B here real quick. And on B, I want to instead do, we'll just do it a little bit differently. Let's say we have 2x plus y squared plus 1 equals 0. Slight variation in those problems. One of them's a function, one of them's not. How do we make that determination? Chat it out quietly with your neighbors. Something. Bad ideas still count as ideas. So, Kalisha, if you're watching this, go ahead and pause it. Think about this. You don't really have anybody to talk to with it, but you're going to hear me start talking about it in 3, 2, 1. Anybody have a good idea? Or an idea? I won't say if it's good or bad. All right. If I asked you to graph A, I think we'd all do the same thing. If I said, hey, I want you to graph A, whether it's by hand or on a calculator, what would you do? Love it. If you didn't see, Rafa did, I don't know if I can do this. This was Rafa's thing. Oh, I know how I'm starting tomorrow's video. All right. What was this that he was representing? So, parabola, maybe. That's not what I interpreted. Do you mean parabola? Ah, you got me good. All right. I read it as this. Nope. As doing this. That's what I interpreted that as. Which coincidentally also kind of looks like a parabola, which is a nice or terrible coincidence. If I asked you to graph this and you have no idea what to do, my hope is that you guys would probably rearrange it like that initially. Okay, super simple question I'm about to ask. Did we solve that for y just now? Okay, so we'll just keep that in mind. I'll tell you, that is a function. There's nothing wrong with it. It looks like this. It's a downward parabola. We're frowning. Okay, if I asked you to graph the second one, would you take a similar approach, especially since we talked about that? Would you try to solve it for y? Does that seem like a reasonable thought that probably based on what you've done before would be where you'd go? So help me out. I'm going to do the first step, and I want you to tell me what I've done. Y squared is negative 2x minus 1. What did I do? Not yet. I've subtracted first, right? But I like your idea. Abigail, you said do what? Okay, square roots. They don't have to be ugly. I'll do the left side. Square root of y squared, it's y. All right, moment of truth. I want to take square root of the second side as well. Tell me why I'm wrong. I'm wrong. Why? Sure. I've hit a couple with you this over the last week and a half. What's the square root of 25? And, ooh, what did I do wrong, JV? Needs to be plus or minus. Now, here's something that makes it so easy to determine. Could we solve both of them for y just now? Could we solve both of them uniquely for y? The left one, we only have a single expression that's y, right? It's a function. The right one is really how many expressions? 2. There's a positive version and a negative version. That fundamental difference is really all that we need. Testing for functions is real easy most of the time at our level at least. If you can solve uniquely for y, then y is a function, and again I'm going to use func, in terms of x in this case. Now the other language you might see is it's a function of x instead, but there I have no issues saying f of 3 or y of 3, and they mean the exact same thing because we're just changing it around. Okay, this is going to be strange for a minute. I'm going to give you a homework assignment that I'll tell you right now is going to be due, it's Thursday. It's going to be due Tuesday morning. Okay, we have done about half the section. We'll knock out the other half much quicker. Maybe, we'll see. Depends on how your piecewise game is. But I'm going to give you an assignment now that's going to be due on Tuesday, 2 classes from now, because we have a little bit more to talk about. But if you want to get a head start on it, you can, but you don't have to. Okay, so the homework that we'll get out of this is homework 1.4, which you will find on page 44. You get the privilege of problems 1 through 14, 21, 23, 29, 35, 45, 49, 58. And I know like it seems so long, but it's just because of all the randomness. But I'm going to hook you up. You get to skip 10. By 10, I mean skip number 10, not 10 of them. Cool. You don't have to start tonight. You'll be able to do a good chunk of it, not all of it. Cool. Tomorrow, we get to start with naming functions, which is going to be a breeze.